All right, welcome to the Explainer. Today, we are jacking directly into the neon-drenched, high-stakes cyber grid of the SexOS microkernel project. If you've been following this single address space operating system, you know the energy right now is just absolutely electric. We've got this elite squad of vibe coders, contributors, and AI agents all flocking to the mainframe, ready to write some mathematically pure, bare metal Rust. But, well, here's the catch. When a project explodes in popularity and develops this fast, the sheer volume of contributors hitting GitHub can actually get pretty chaotic. I mean, with that many devs and AI tools moving at lightning speed, how do you actually prevent merge conflicts? How do you stop architecture drift, or keep people from constantly stepping on each other's toes? Well, that's exactly what we're tackling today. We're going to map out the perfect workflow strategy to synchronize our squad, eliminate the friction, and push this project forward flawlessly.
Okay, so here is the mission briefing. We're going to look at the OS boom, the danger of vibe coding, and the source of truth. After that, we'll dive into the AI sniper squadron, the auto-remediation ledger, and finally, the unbreakable gate.
Starting off with Section 1, the OS boom, hackers hitting the mainframe.
Right, so our ultimate objective here is massive, but simple. We want to push this project forward to 100% completion. But look, getting to 100% on a capability-based microkernel, it isn't just about writing code fast, it's about writing code together. With GitHub absolutely lighting up with pull requests, we need a perfectly synchronized workflow. We want everybody to benefit from everybody else's work, without anything conflicting. It's really all about taking that raw, awesome contributor energy and channeling it through a flawless system, so every single commit actually drives us closer to that finish line.
Which brings us to Section 2, the danger of vibe coding, hallucinating the grid.
So, what actually goes wrong when dozens of developers and AI tools all try to vibe at once on a highly specialized architecture? Well, the core problem is that standard AI models often act like bulldozers. They tend to write Rust as if it were just your everyday Linux desktop app, throwing in standard libraries, threads, async runtimes, the whole shebang. But our reality is completely different. SexOS is a strict, no-standard library, bare metal microkernel. It completely relies on hardware memory protection keys, Intel MPK or PKU, and Protection Domain Exchange IPC. It is a single address space. So if a vibe coder or an LLM hallucinates a standard POSIX assumption here, it doesn't just crash an app. It literally compromises the isolation boundary of the entire operating system.
To fix this, we have to enforce some strict discipline. This is not Linux user space. No POSIX assumptions, strict no STD Rust microkernel. That is essentially our golden rule. Whenever a vibe coder or an AI agent steps up to contribute, this exact mandatory template absolutely has to be dropped into the LLM prompt. You have to explicitly tell the AI what environment it's in. Forcing this embedded kernel server thinking right up front is exactly what prevents those freestyle AI disasters. It makes sure every single line of generated code actually respects the strict capability isolation of the OS.
Moving right along to Section 3, the source of truth, the master contract. Now, if we have a massive squad, we absolutely need a master contract to keep everyone aligned. We have to eliminate duplicate truth layers. In the past, the project had these scattered markdown files, JSON locks, and grep rules, all trying to somehow hold the architecture together. But no more. OS SexOS contract.toml is now the supreme law of the codebase. It is the singular, authoritative layout of the OS capability routing and IPC application binary interface. Every single rule, every slot, every register assumption derives directly from this one file. If you're coding, you don't guess the architecture. You look at the contract. This perfectly prevents any two developers from ever arguing over or stepping on the system's ABI.
Next up, Section 4, the AI Sniper Squadron, Precision Instruments.
So how do we actually harness the incredible power of AI to hit that 100% completion rate without breaking our super delicate bare metal system? Well, instead of standard brute force LLMs that just burn tokens and create massive noise, we use precision instruments. We've got an incredible arsenal deployed here. There's the Codebase Investigator to safely map dependencies. We have the Build Noise Nuker that literally ignores compiler spam and extracts only the first fatal error. We've got the ASM Sniper and the AST Unsafe Tracker to surgically verify hardware boundaries and unsafe Rust patterns. And when it's time to actually write the code, the Sex Editor steps in. It's a surgical patcher that strictly requires a human yes or no confirmation before it alters the kernel. This entire suite keeps your main session lean, highly efficient, and totally safe.
That brings us to Section 5, the auto-remediation ledger, the deterministic loop.
This is our ultimate developer safety net, and I really want you to take this core philosophy away with you today. In this workflow, the AI is not the compiler. The AI is the compiler engineer. We aren't just letting an LLM blindly mutate code until it happens to compile. Instead, we're using the AI to learn structural rules, and then we persist that behavior in a deterministic ledger. So when a structural incompatibility happens, maybe a bit flag's version drift or an alignment issue, we only have to document it once.
Let's actually see how this deterministic loop executes in practice. When you build the code, the tool intercepts the build errors. If it recognizes an error from our ledger, it takes the fast path. It surgically applies the known fix to the abstract syntax tree in literally 5 milliseconds, without ever even touching an LLM API. But if it's a new error, it takes a slow path. The AI agent diagnoses the issue, fixes it, and then writes a brand new rule right into the ledger before recompiling. Basically, this means the system continuously learns your recurring bugs and fixes them instantly for everyone else on the squad. You're never, ever solving the same bug twice.
Finally, we reach Section 6, the unbreakable gate physical CI rejection.
How do we bring this all together to protect the main repository? We enforce it with a continuous integration pipeline that physically rejects bad code right at the repository boundary. This isn't just linting, okay? It's a physical gate. First, in phase 25.0, it loads the single source of truth, the TOML contract. Then, it locks the ABI, making sure no legacy code leaks through. Next, it compiles the type state machine, which means invalid states literally refuse to compile. Then it hits the CI gate and does a full build and boot verification. This entire deterministic pipeline enforces the architecture completely automatically. That means no vibe coder, no matter how enthusiastic they are, can ever accidentally break the main branch. The system physically protects itself.
So the squad is perfectly synchronized. The master contract is locked tight, the AI snipers are loaded, the ledger is continuously learning, and that CI gate is totally unbreakable. We have built the perfect workflow strategy where every contributor's work compounds without conflict. So the only question left to ask is, are you ready to jack into the microkernel, use this flawless workflow, and help us push SexOS to 100%? The cybergrid is waiting for you. Thanks for joining me on this explainer, and happy coding!